I've known Russel Winder, as we were talking about earlier, for what, 10 years more? Probably getting on for 15 now, isn't it? Yeah, a long time. And some of you will have seen Russell speak here before, not at SyncConf last year, but here before. Sync Norwich.
Sorry, no.
I'm
Virgin.
Yeah, yeah, okay, cool. I'm not doing very well at not saying very much, am I? So I'm just going to hand over and Russell can...
Okay, well, just to... the air of mystery with the walk-on music. Several species of small furry animals gathered together and gave and groovying with a pick. I see, now you know.
Pink Floyd for anybody who's not sure.
Pink Floyd, indeed. Which is why the Careful With That Axe Eugene was an appropriate prompt for people. And if you don't like the talk, we do have an axe. We can take... never mind. So, why indeed? And as we know, we've got Inquisitive Spock, who wants to know the answer to this, which is a great way of feeding into the Spock workshop tomorrow, if anyone wants to go to it. Okay, so the premise of this, what was it, 28.5 minute talk?
Yeah, something like that.
Yeah, okay.
I'll stop you when I've had enough.
Fine. So, who's using Java at the moment? Which version? 5? 6? 6? Okay, so if you're on 6, you're doing it wrong, because Oracle don't support it anymore. So it's an unsupported product. So Java 7 is the only one that's in support, unless you pay huge amounts of money to Oracle. Or perhaps you're on IBM things and paying huge amounts of money to IBM instead.
Unfortunately, we're paying huge amounts of money to another vendor, and they only support Java 1.6.
Well, they're clearly broken.
Yes.
Java 5 was a revolution apparently in Java, though some people refused to use Java 5 because 1.4 was good enough. But Java 8 really is a revolution. Anything before Java 8 is a waste of time. Just forget it. Because when you move from Java 7 to Java 8, your entire world will change. I'm just going to exhibit one, perhaps two little angles of it, rather than try and say everything about Java 8, just to keep it down to 28 minutes and keep you guys interested. So the summary of the overall changes is G1 garbage collector. You will like the G1 garbage collector. You will like the G1 garbage collector. If you've got Java 7, one or two people have Java 7, you can use the G1 garbage collector now, but it's not the default. You actually have to explicitly do it. If you're on Java 6, sorry, it's back to real pain. NAS horn, apparently it's a nose horn, which means it's a rhino, which is why the joke, because NAS horn is an implementation of JavaScript. Well, forget that page, let's have this page. No more permgen. We like no more permgen.
But it's, J1 was set to not work, to not be efficient before 1.7. So you think on 8 it will really work?
Oh yeah. It does on 7 as well, after U51.
Okay.
Works fine. This is trying to keep all the Node.js guys happy, I assume. Actually, it's very good. NASHorn is very good, very fast these days. But this isn't anything about JavaScript, even though it's a dynamic language. JavaFX is integrated, but if you've actually looked at the distribution, the documentation isn't integrated in. You just get the artifact in the distribution. You have to get the documentation separate. The Groovy FX talk, completely different one, we won't go there.
Will it be part of OpenJDK or will it be open source? Or
Yeah.
Will it be,
Yeah, it's all queued up to be fed straight into OpenJDK. I think there's one or two legal things they've just got to sort out before March the 17th. This is the real point, is Lambda expressions. The collections enhancement are a consequence of the Lambda expressions. So I just want to bring out 2 points about Lambda expressions that show you the revolution that's happening supposedly on March the 17th. which is at the date that they have set for the meeting that will issue, or rather Oracle will release it, hopefully. Java's verbose, isn't it? Yeah, we'll go with that. So these ones haven't been verbose. The whole point of these languages is that they're not verbose. So, question to the audience number one, which language is that? Actually, no, it's not Java 8. You can tell it's not Java because the type comes after the variable.
Haskell? Erlang? Guessing here.
Groovy.
No, it's Scala. So this is the language that's sweeping the finance industry in London. You get rid of Java, go to Scala. Except where you get rid of Java and go to Python, which is what an awful lot of finance folks are doing.
Or Sharp?
Not much compared to Python. Oh, right, cool. Well, you've got different clients to me, so we're seeing different sub-slices. Okay, so which language is that? We heard the music, we heard the picked, we are now groovying. So this is Groovy. And just a quick tour, curly brackets, block of code, introduce the parameters to the block of code with a little arrow, and here's the expression. So we've got Clojure, tiny little functions that we can pass around, and in this particular case we've got a variable multiplied by 5. It is just a variable, it refers to a code object. All the wonderful things you can do in dynamic languages you can't do in Java. Do people use JavaScript at all? Yeah.
Quite a lot in Norwich.
Sorry?
Quite a lot in Norwich.
Quite a lot in Norwich. So JavaScript is very similar in many of the dynamic aspects to JRuby, Jython, Python and Groovy. The important thing here, of course, is that we are using our variable, refers to an object, it's callable, we can send in the call message, lots and lots of object-orientedness, unlike what you're doing with Java. Java is not an object-oriented language. A question I throw out to the audience for when we go for food and drinks afterwards. We can have that debate. You will sometimes have to do this. That's a problem in the JVM. You can't always convince it to redefine a function call quite as nicely as you'd like to. So occasionally in Groovy code you'll see the dot call specifically. Nice, really nice and groovy. There are so many functions of one parameter flying around that by default a code block has one parameter and it's called it, and so you don't need it. If you actually want a code block with no parameters, you have to put an arrow in there with nothing in front of it. It says, oh, it's a code block, no parameters. So the default in Groovy is you always have functions of one parameter. It really does make life easy when you are chaining and using fluent interfaces. You probably recognise this language. Okay, so this is the mess that you get in Java. This is verbosity enshrined in the language. So go back a slide. Groovy. Java.
Less groovy.
Sorry?
Less groovy.
It's definitely less groovy. And you can't overwrite the function call. So there's a critical point here. It says, we have a reference to a code object, we can call it. In Java, you have no such capability because there is no notion of a code object separate from the class. Yeah. So it's really, really annoying. I think in 1990 when we were doing green and all that sort of stuff, they thought that Java programmers weren't going to be trusted with the ability to redefine operators. And so everything had to be a method name. That's all you were allowed to do. I think that's a bit condescending of them, actually. And one up to C++ for staying with it. So with all that extra verbosity, and so why are you guys using Java?
I like it. We get paid by a line.
This is what we like to hear. Proper rationale for why you want to have lots and lots of boilerplate.
There are jobs in Java?
Yeah, apparently so. Okay, so Java 8. This is Java. Okay. Are you shocked? Interested? Threatening to go and work for a company that used Java 8? They've almost got it right. Here we have, this looks very groovy. That's because they got it right. And if you, let me just do it. If we go back here to, I've not shown that one yet. I'm getting slightly ahead of myself. Back to the main argument. This looks like a little bit of code object because that's exactly what it is. But it's not actually a code object. What you create is a nice little trick using method references and invoke dynamic to actually do code generation at runtime on the fly. And so Java is although it is strongly typed at compile time, what's actually happening with these little functions is not, I'm going to create an object and put it. That actually happens at runtime. And it's a brilliant trick that the guys came up with, which avoids the problem of having to build lots and lots of classes because that's what the JVM says you have to do. One of the problems for Scala and why its compile time is so long is because this is actually how they implement a lot of their function objects, using classes like that. So, Java 8, I find this impressive. The audience doesn't seem quite as impressed yet. Got a feeling why you don't like it?
So, you've got to define that Clojure interface. Do you have to do that?
Yes, yeah, because what you're doing here is giving the information to the compiler about what's going to happen at runtime in terms of code
So
generation.
it's only slightly less verbose.
Well, I don't know, would you prefer to write that?
But it's not groovy.
No, it's not. No, definitely not groovy. But they did take the groovy syntax rather than the Scala syntax, which I thought was cool. Okay, so that's point one, is Java will get these things. Sorry? Oh, yeah. Okay. Now, one of the big complaints in pushing Groovy is it's a dynamic language. It's slow, interpreted. Yes, sort of. It is actually compiled down to JVM, but it does have a full meta-object protocol. Exactly that the guys in Project Green said Java programmers weren't going to be able to cope with. So Groovy folk are slightly less, what's the right word for it, condescending in terms of language design. We have a trick. No, the jokes aren't working, are they? We can compile Groovy statically. And that gets full runtime type checking. And if you force me to, I can show Groovy running faster than Java. Yeah. So notice I've had to put in a type there because we're having compile time type checking. So you lose the ability to have typeless parameters. You're forced back into. So that's, but it's a trade-off that's worth having. Because what we've now got is Groovy as a language that is both dynamic, if you want it to be, or static, if you want it to be. In other words, I never need to write a line of Java ever again. And yet I can get Java performance using Groovy because we have full static type checking and full static compilation. And it compiles out at compile time the meta-object protocol so that the call sites are real Java level, JVM level call size, not a meta-object protocol with lookups and all that sort of stuff.
What's the scope of that compile static? I mean, do you have to list that all over the code, or?
In this particular case, for this example, I've put it on the function because that's what code is up there. In the examples I've got, I would put it on the class, and then everything in that class will be fully type checked and compiled out. One or two situations where you have to say, yes, I want this to be statically compiled, but you can't do the type checking because it's still got a runtime element to it. If we had an hour and a half, I'd go a lot more into it. This is really just a taster to give some signposts to say, these are interesting things. So,
there's a compiler option as well. Would you want to?
sorry?
You said it's a compiler option.
There are a whole load of compiler options you can put in there. If you want to have your entire Groovy program always statically compiled, there are options you can give to a project that will say everything is statically compiled, and you don't have to put any annotations at all. It's just I prefer not to do that, because I like to have one system with dynamic bits and static bits. We like this, don't we? Maybe. Okay, the other big thing that's coming is that consequence of these Lambda expressions is the changes to the library that have had to happen. And I've just pulled out one as an exemplar to try and whet your appetite. And it's trivial, it's academic, but then it's small and it fits on one page. So we're going to calculate the sum of squares of numbers between 0 and 100 that are divisible by 7. And so the algorithm is the sum of the squares, there's an expression of that somewhere, 0 to 100, so there's some iteration going on somewhere, and when we're making a choice. So how many people would write that bit of code? I think perfect. If you're coming from Java 6 and Java 7, given that statement of intent, you'd come up with code looking like that. It's quite natural, because that's the sort of thing you would do.
Is it the square that's divisible by 7, or you know?
Well, now we're getting into requirements capture and interpretation of the needs and
Whatever you do, it'll be wrong.
yeah, basically that's what it comes down to, isn't it? So, completely different way of thinking about it. And this is the angle that Scala has brought into the game, is finally, after 35 years of warfare between object-oriented and functional programming, someone's had a successful go at trying to find a route through the meld of the two. And so what you've got here is this is not a for loop, this is a comprehension which says that there will be 100 items and we will deliver them, and it's actually an iterable and it's slightly lazy and all that good stuff is going on there. And then the sum is actually a function, but within Scala you're allowed to drop off the parentheses in most situations. So classic piece of Scala approach to lots of data, reduce. So it's a map reduce problem that's going on here, except we're not allowed to call it map reduce because otherwise Google will be after us for royalties. No, that one didn't work either, never mind. Okay, so what language is that, do you think? This is really an unfair question, of course, because...
Scala again?
No, it's not Scala. It's still a comprehension, but now we're in Ceylon land. So this is a way of doing it for those who like tea rather than coffee.
That one worked.
But it's still a comprehension. The curly brackets are just a syntactic mess that they had to put in. So there's our for, if. So you've got some sort of driver, you've got a filter, you've got a map. So you take a value, filter it, and then map it onto some values. Trick question, just in case anybody's actually awake. Nothing to do with the JVM, this is Python. Here's the generator expression, filter expression. Overall, this is a generator expression, not a comprehension. because it's creating an iterable rather than a data structure. And that's a common theme coming through Java 8 now, is that you're interested in iterables because you want things to be as lazy as possible. Another thing that's come out of Haskell and functional programming. Yeah, that one is Scala, and here they've just got the wrong syntax. They chose the wrong symbol there. And then there was a big hoo-ha whether Java 8 should have an equal sign or minus sign, and they chose correctly to be Groovy. Okay, I'll just throw that one in. You won't know. It's Kotlin, which is sort of JetBrains' answer to what language follows Java. They were looking at Groovy, but we didn't get compile static in fast enough for them. So they decided to write a new language because they've had enough of maintaining IntelliJ in Java. They want something less verbose. Let's not worry too much about that. That's a trick question one. Aha! We have arrived at grooviness. You know it's groovy because they use the wrong words here. Instead of map, it's collect, which comes straight out of Smalltalk. So it's showing that Groovy has a Smalltalk heritage in terms of the names of these operations. But you know, we've got some iterable, we apply some piece of code, and then we do the reduce on it. The point here is that there's not a single explicit iteration inside. And that is one of the big things that is coming with the Java 8 library, is that you get rid of an awful lot of for loops. Because instead, you have your iteration hidden in these functions. And it's a balance between explicit and implicit. And implicit wins because you then get parallelism for free. You could, if we were doing Java 8, which we will do momentarily, let's just skip that one for now. Here's a Java 8 version of exactly the same thing that we started with. So you've got some type stream, we generate a range from that. That's just classic Java object-oriented. You've got a class, you've got a static method on it, out comes an iterable. Then, interesting stuff. Implicit iteration. Here's our little Lambda expressions. We apply filter, then map, and sum. Classic functional programming. Anyone who's done Lisp, Haskell, any of those languages, they look at that and say, yeah, I can, well, you're doing it in the wrong way. It should be a function applied to rather than something dot. But they say, yeah, this is functional programming. This is good stuff. And why is it really, really good? Because in there, we can put the word parallel. And the whole thing just happens in parallel. The beauty of the streams in Java 8 is that you are going to get data parallelism for free. Effectively, just by chaining your implicit iteration, which is connecting together iterables, you can say, oh, this is sequential. I want it to be parallel. And then it will pull out the fork join framework, say, oh, you've got 8 cores. I will have 8 threads in the pool, and we will farm the work out. So the Java 8 streams are a really good thing. And yet you can do it in Groovy. The point is that this sort of stuff, you just roll out gpars, and you put parallel in here, and it just sits on top of fork join framework and works on Java 6. So with Groovy, you can do all this stuff that you have to wait till March 17th to even think about asking your people to move to Java 8. And going from Java 6 to Java 8 is probably the right thing to do.
That's assuming it comes out on March 17th.
Yeah. Well, Mark Reinhold's neck is on the line.
I wouldn't put any money on it.
No, I probably wouldn't either. But here, it's the same approach to programming. You've got static compilation, you've got compile time type checking, you've got dynamic behavior if you want it. And so I don't see any reason why we have to wait to achieve these goals of doing this sort of stuff. You guys on Java 6, if you want to do this sort of stuff that the Java 8 people are going, it's great, then you can do it yourself with this stuff. So why wait for Java 8? Just use Groovy. You've got static compilation. It's all extremely cool. No, wrong way. Yeah, no, he likes it. So I think I'll just ask if there are any questions, really, because we've got about 4 minutes for chit-chat.
Question, what's Spock? Now who it is, just Spock, what?
Ah, right. It's a unit test and a system test framework. It's Groovy based, but you can test anything that's a class file. So if you've got Java code, you can get rid of JUnit3 and JUnit4 and test ng and just use Spock. And it sits, if you like, between the JUnit4 and test ng and Cucumber. So you get a lot of the sort of Cucumber-like facilities, but at the same time you can do all your unit tests. And people are really, well, I was about to say raving about it, but that might give you the wrong impression. They're not lunatics, they're raving about it because it's very, very good and is the way forward.
We've just started, well, I started looking at it when I'm about mandated for everyone. So,
Yeah, it's that good.
And 90 minutes with it tomorrow.
But it's a workshop, not a chat.
Obviously the tend to adopt functional type stuff. How is the Clojure stuff going to sit the likes of things like currying and partial function application? How long is it going to take for that kind of audience to pick up? I mean, I'm working with C# people who still don't even get delegates in C# and how you can use them and compose them.
Yeah.
I'm wondering whether you think it's already working under a peer, but how do we kind of, how much further does it need to go, or do you think it's sort of?
Well, that's why I've chosen examples like this one, which
like
don't
simple,
worry, because they will apply to a large amount of work that people have, and these are much easier to deal with than all the delegate stuff, which will take a while. The main entry will be anything that's event-driven, where you've had anonymous classes and instances of that. You just replace it with these things, and your code goes woof, and is way more readable. And for that alone, I think Java 8 is going to be a huge win, because anything event-driven, GUIs, networking, all those anonymous classes go, and you just get these small little functions.
You still define the interfaces, but to your point, I mean, that's not the big issue. It's the number of times you actually then have to implement it as an anonymous class in Java that causes all the
Yeah, this is not the problem. It's getting rid of the mess that you would have to do there. And it's the number of times. So yes, it's absolutely right. And people who are using Java 8 for GUIs and stuff already are finding their code just becomes much more maintainable.
So even though you've got closures after C++, it's still even more verbose than C++, which is naturally quite nice. So that's sort of ironic.
I think we'll have to take that C++ debate elsewhere, because C++ have got hash include, which is just anathema. So I think I should probably leave it there. It's sort of two-pronged message. One, Java 8 is really good, but Groovy is even better. So I think I should leave the floor.
Thank you very much.